let's understand another concept called coprimes, are also known as relatively prime numbers. This would help us to actually expand our understanding on divisibility rules. So let's look at two numbers. So coprime numbers are not like prime numbers. Not that you need to have prime numbers. Coprime numbers are basically they are prime to each other. So I need a pair of numbers, right? That's why it's also called relatively prime numbers. So let's look at a number like 3 and 4. They are coprime actually. So how do I check if two numbers are coprime? The common factors, right, among these two should be only one, nothing else. What are the factors of 3? 1 and 3. For 4, I have 1, 2, and 4. See, 1 is the only common factor I'm seeing, right? Uh, let's take 12, 1, 28, right? Or rather, I'll take 12, 1, 20. At 1, 2, 4, 5, 10, and 20. Here I have 1, 3, 4, 2, 2, 6, 12. See, I have 1 and 1, 2 as well, 4 as well, right? So the common are actually more than 1, right? I'm only seeing 1, 1 in this case. So these are coprime. But here I'm seeing 1, 1 is not the only thing. I'm seeing also 2 and 2, 4 and 4. So these are not coprimes, right? So these are very important to understand that if I take two numbers, have a clarity on whether those two are coprime or not, right? For example, 12 and 7 are coprime because as I know the factors of 12 are 1, 2, 3, 4, and 6 and 12. So automatically 7 is not in the factors, so it's coprime, right? Now, so divisibility rules of some standard numbers are being covered. Let's look at the non-standard number. What do I mean by non-standard? It can be any numbers which we haven't covered earlier. Those are the very commonly seen and the basic ones. Let's talk about the divisibility rule of 6. Okay. So for 6, it's not in the list of the numbers we have seen. So that's where you have to actually basically split this into two numbers, right? Two numbers which we know the rules, but the idea is those two numbers should be co-prime, right? So I can split as 2 and 3. Are these two co-primes? Yes. 1 and 2 are the factors, 1 and 3 are the factors. 1 is the only common factor, nothing else. So that's why they're co-prime. So if I ask you if a number 1, 2, 3, 4, 5, 6 is divisible by 6, I don't check for 6 directly because I don't know any rule for that. I would rather check for 2 and 3. If a number is divisible by both 2 and 3, automatically it is divisible by 6, right? So I know the last digit is 6, which is divisible by 2, so that's why this is divisible. For the 3, I know the sum of digits is 21. 1 plus 2, 3 plus 3, 6 plus 4, 10, 15, 21 is divisible by 3. So it is divisible by 3. So that means the number is divisible by 6. Keep in mind, if you don't really split this into co-prime factors, it will really mess up your answer. Let me ask you a question like 348, right? Is it divisible by 8? So don't try to do this again. 2 into 4. 2 4, I know the rule of 2, I don't know the rule of 4, and I'll check for both. See, these are not co-primes because it's 1 and 2, it's 1, 2, and 4. 2 is also there along with 1 and 1 as common factor. So these are not co-primes, but you still go ahead and do it. Is 348 divisible by 2? Yes, the last digit is 8. 8 is divisible by 2. 348 divisible by 4. 4 2s are, sorry, 4 12s are 48. So yes, 48 is the last two digits are 48 and divisible by 4. Hence the whole number is 348 divisible by 8? Obviously, I have to look at the last three digits, but rather just do a normal. It's only 3 number, right? 8 4s are 32. I'm leaving a remainder 4. These two are divisible by, like 348 is divisible by 2 and 4, doesn't necessarily make it divisible by 8 just because these two are not co-primes. See, this is really important to understand that I have to split the number into co-primes and also obviously numbers which I know, right? So let's just get another example, like 1 2 3 4 5 6. divisible by 36, right? How do I split it? I can split it as 4 and 9, right? These are co-prime. I know the rule for 4, I know the rule for 9, right? I can't split it as 12 and 3 because these are not co-primes. I have a 3 as a common factor between these two as well. So that's why it's not a right way to split it. So 4 and 9. So divisible by 4. Last two digits 56. 14 4s are 56. So yes, it is divisible by 4. The sum of digits is 21. Is it divisible by 9? No. That's why it is not divisible by 36. Right? So that's it on the concept side. So let's get started with some problems. So now this is a number and we are talking about non-standard like 6, 12 and 33. Let's first get to this 6. I can split as co-prime as 2 into 3. 12 is 4 into 3. 33 can be written as 11 3s, right? These two are also co-prime. So these are the standard numbers I know: 2, 3, 11, 4. The divisibility rules for this. So 1, 8, 7, 4, 3, 2. Divisible by 6. I'll check for first 2 and 3. Last digit is 2. Hence it is divisible by 2. Sum of digits is 1 plus 8, 9, 16, 20, 23 plus 2, 25. Is not divisible by 3. Hence the whole number is not divisible by 6. Right? So automatically for 12 also the rule is to check for 4 and 3. I'm just doing it for a better experience. So 32 is the last two digits is divisible by 4. 4 is there. But this is not again divisible because sum of digits won't change. That's 25. Hence the whole number is not divisible by 33 is 11 into 3. So I have to check divisible by 3 and divisible by 11. I know that the sum of digits is 25, so it is anyways not divisible by 3. So I can stop here itself, but just to revise you the 11 experience with doing that. So 33, sorry, 11 is basically I have to do the alternate digits, right? 2 plus 4, 6, 6 plus 8, 14, 3 plus 7, 10, 10 plus 1, 11. I don't know why we always end up with 3 as a difference, but yeah. So the difference is 3. It's not divisible by 11. Hence, this number is not divisible by 33. Right? This is how you do for the complex numbers. Now, this is slightly on the advanced level. So, I'm saying what is the maximum value of x plus y? So, basically, x and y are the digits here. 34x, 64y is the number, is divisible by 12. So, I can have potentially some values for x and y such that the rules of 12 are satisfied. So, I have to find the maximum in that. Right? So first again I have to split this into co-prime. I'll check this as 4 and 3, right? So what is the number? 34x 64y. So if a number is divisible by 12, it is divisible by 4. So what is the divisibility rule of 4? It is 4y should be divisible by 4, right? So that means what are the potential values for y? So what are the 2 digit numbers starting with 4 that can be divisible by 4? 40 is 1, 44 and 48, right? Nothing else actually. So potentially y can be either 0, 4 or 8. What is the rule for this? It says 34 x 64y should be divisible by 3 as well if it is divisible by 12. So that's basically sum of digits, right? 7, 13, 19, 23. So it's basically 23 plus x plus y should be divisible by 3. One thing you have to understand is x and y. What is the minimum I can have? 0 and 0 to maximum is 9, 9, right? That's the maximum and minimum a digits can have. I can't have 10 as a digit here, right? It has to be only 0, 1, 2, 3, so on up to 9. So the minimum I can have is basically 0 plus 0 and maximum is 18, right? So that means this 23 can be varying from 23 plus 0 plus 0 to 23 plus 9 plus 9. So that is 18 plus 23 is 41. This is 23. So now I have to ensure that it is also divisible by 3. So what are the potential multiples of 3 in this zone? 24, 27, 30, 33, 36, 39. right? Why did I do all of this? Because I have to ensure that this number is divisible by 12, which means should be divisible by 3 as well. So the divisibility rule of 3 gives me that it should be 23 plus x plus y. That's the sum of digits. So that means the potentially x and y can be 0, 0, that's the minimum, or maximum is 9 and 9. It can't be beyond this, it can't be lesser than this. So I've just picked the multiples of 3 in this zone so that I can ensure that this number is divisible by 12. Right, so because I need to have the maximum, I'll start to look from this side, right? So 39, 23 and 39, right? So what can be the x and y? Y is basically 39. So I can have 9 and 7, right? 7 and 9 obviously. 8 and 8, 8 and 8, right? 9 plus 7 is 16, 7 plus 9 16, 8 plus 8 16, 8 plus 8 16. So that's where 33 plus 39 gives me this. So why did I take the maximum? Because that's when I can have the maximum for x and y. If I take this, so I'll have x and y as 24. That means x plus y should be 1. So I'll have 1 comma 0 0 comma 1. So these are not going to give me the maximum for x plus y, right? The question asking me to find the maximum. So see, one another constraint I have based on the divisibility rule of 4 is that y should be either of this 0 or 4 or 8. And I see this as a possible option, right? If x and y both of them are 8, so that is the number is 34, 8, 64, 8, right? It is divisible by 4 because the last two digits are 48 is divisible by 4. It is divisible by 3 because the sum of digits would be 39. So hence the maximum I can have for x and y are 8 comma 8. So that's the maximum is 16, right? This is definitely a complex problem. Do check this video again if you are confused about how we have done. But this would actually clarify your concepts on the divisibility rules on the bigger level, right? So that's it for this class.